remaining logic gates, that is ECL and MOSFET. Today we are discussing ECL, emitter coupled logic. Emitter coupled logic is based on BJT but removes the problem of delay time providing the transistor from saturation. Here, normally in case of any switching, the transistor moves between cutoff and saturation. Now here, the transistor configuration is such a way that transistor moves between cutoff and inactive ratio, such that the propagation delay will be less. So very fast operation. Propagation delay is of about 1 nanosecond or less, but power dissipation is high, perhaps 60 nanowatt per volt. Here, logic level 0 is considered minus 1.7 volt and logic level 1 is considered minus 0.8. But it is not a negative logic, it is a positive logic because the high level is towards ground, means less negative, and logic 0 is high negative. So it is a positive logic, but in terms of negative voltage. Here, such ECL that has no noise immunity of about 0.2 to 0.25 volt used in some high-speed specialist application, but presently all these ACL gets now replaced by the high-speed CMOS. The basic circuit of ECL. Basically, ECL configuration is like a differential amplifier. Here, two transistors are coupled. Here, one thing, why it is called emitter coupled? Because emitters of all the transistors are coupled together. So here, input one transistor Q1 and Q2, both emitters are coupled together and connected to a negative voltage of minus 5.2 volt. So it basically gives minus VE provides a constant current source of about 3 milliampere. Now this Q2 transistor base is connected to a reference voltage that around voltage is minus 1.3 volt, and based on the input voltage which is greater than VDD or less than VDD, based on that either of the transistor will in active region and other one will be in cutoff region. So when VE is considered in logic low, logic 0 means low potential minus 1.7. That means potential difference between the base and emitter is less compared to the base emitter voltage of Q2. So transistor Q2 will hold in more conduct. That means here the transistor Q2 will be in conduction mode, Q1 will be in off mode. As it is off mode Q1, the potential here will be equal to the ground potential. So here we get 0. 0 potential means equal to logic high, and here what we get as find is here, so potential is minus G1. G1 is the voltage required to own the transistor. So what we get if input is logic 0, so we get here high logic at DC1, low logic at C2. Similarly, if we consider it is logic high, means potential difference here is less. At that time, this transistor is in conduction condition. So potential at that point we get minus V1. Here potential we get 0. So what we get basically here at DC1 we get inverted form of input, and DC2 we get equal of V. If V is logic 0, DC2 we get logic 0. This one is logic 1. If V is logic 1, then DC1 is logic 0 and DC2 is 5. Now, based on that configuration, the values are considered like G in is equal to VBB, means reference voltage of transistor Q2 plus minus V1 by 2, and VBB is minus 3 V1 by 2. In such a way, consider the voltage is such that neither the transistor goes into saturation, will be in cutoff or in active ratio. Now, if we see here, input voltage changes from minus G1 to minus 0.0, minus approximately minus 0.8 to minus 1.6 or 1.7. That means double, means G1 level. minus 0.8. So input voltage varies from minus V1 to minus 12 V1, but output voltage changes from 0 to minus V1. So there is a fallacy between input and output voltage level. In earlier TTL or other logic circuit, what you consider input consider if you consider 0 or 0.4 up to, that is logic 0, at the logic high also 0.5 volts. So input output voltages logic 0 and logic high both are same. Logic 0 0 voltage, logic high is 5 volts in both cases, input and output. But in this case, input logic 0 is corresponding to minus 2 V1, logic 1 is minus V1. But at output voltage, it is minus V1 to 0. So there is a difference of logic level between input and output. So to overcome that problem of input output variation of the voltage, the emitter follower circuits are incorporated in that two output. So from DC1 is connected to a emitter follower, from DC2 emitter follower is. So when the voltage at this Q2 connector is suppose minus 0, so this transistor another required minus 0, so output from this when we consider, then it will be minus 2 V1. When the voltage at that point is 0, then we get minus V1. So it will vary from minus V1 to minus twice V1. So that can be overcome by using the emitter follower circuit. Now in the circuit, the negative voltage is considered. So here, same logic we may consider here, which is ground, that we may consider as a positive, and this one we may consider negative. But by considering the negative voltage, some problem can easily overcome. Basically, to avoid the source noise, there is a source noise that can be overcome, and it can provide the short circuit protection. Because if it is connected, the output is connected shorted, and it is going to ground, so there is no problem. So because of that, the negative voltage is considered, and two emitter follower transistor are accepted. ECM or not logic. So circuit is same as the previous slide, except in input in one we consider two input A and B. Otherwise, circuit is same. So when A and B both are 0, logic 0, that means the transistor this Q and Q1 will be turned off while Q2 will be in conduction. So its collector will be low. So to low. So V out2 will be high and V out1 will be high. Sorry, V out1 will be high and V out2 will be low. If either of A and B is high, if A Q1 or Q transistor input is high level, the transistor Q or Q1 conduct, that is this will conduct means the current will go through this, Q2 will be in off state. So its collector is in high state. So V out 1 will be low. So if any one is high, 0 1 or 1 0, so this output will be high. Sorry, low. V out 2 is high. So this will act as basically this V out 1 act as a NOR gate, V out 2 will act as a OR. What are the limitations? Each gate basically continuously drawn the current because either it start up in or in active region. So when it is the active region, continuously drawn the current. So means it requires more power or power. Power will be dissipated more. That means extra power is required. PCL suffers from small noise margin, which can be a troublesome problem. The MOS digital integrated circuit. Basically, MOS considerable low energy consumption than TTL and ECL, which has made up portable stable electronic possible. Most widely used family for logic scale devices. Combine high speed with low power consumption, usually operate from single supply, excellent noise immunity of about 30% of supply voltage, and can be connected to a large number of threads, about 50 numbers. MOS are of three types: CMOS, NMOS, CMOS. CMOS means its channel is P-type enhancement type MOSFET. NMOS means it uses N-channel enhancement MOSFET. NMOS has a greater packing density than the PMOS. CMOS, it uses both P and N channel devices. It has greatest complexity and lowest packing density among the MOS family. It has much lower power distribution, very high input impedance, and very high noise impedance. But it has one disadvantage, that it's low speed due to high input impedance. Now, N-channel MOSFET inverter means N-channel MOSFET not good. So, in case of N-channel MOSFET, when the gate, this is drain, this is source, this is gate. So, when gate voltage is low, MOSFET is cut up region. So, whatever the voltage at VDD, it gets same and down. So, when input is 0, output will get high. When input is high, then this MOSFET, N-channel MOSFET will go on going into saturation. So, voltage at that point will be ground potential is 0. So, when input is 0, output is high. When input is high, output is low. Now basically the circuit, both the circuit are same, but basically the resistance RT is replaced by another N-channel MOSFET, because in MOSFET technology, the resistance implementation is more complex in the MOS implementation. So the resistance RT is replaced by another MOS, rather its drain and gate are connected. Means this is always Q1 MOS is always one step. So depending upon the input voltage, we get the output voltage. Internal MOSFET, NAND and NOR. So basically, this Q1 is act as a load, Q2 and Q3 connected in series. So when AB is high, that means Q2 and Q3 conduct, hence output voltage will be equal to ground potential. So when AB11, output will get 0. If either A or B or both are low, that means either of the N-channel MOSFET will be off or both will be off, so either no current will flow through this Q2 or Q3. So output will be high. So this circuit will act as a NAND. The right hand circuit acts as a NOR. Here A transistor Q2 and Q3 connected like a parallel, and Q1 acts as a load. So when A and B both are low, that means Q2 and Q3 are off state. So what we get at the output? The output will get equal to VDD, that is high. When either A or B or both are high, that means the corresponding MOSFET will conduct or both will conduct, either the potential at that point will go into ground potential, that is low. So when A or B or both are at high level, output will get low level. So this right hand circuit will act as a NOR. Internal MOSFET, AND gate and OR gate. Basically, this AND gate basically performed here, but designed in such a way that first one is basically the left hand part is NAND gate, and Q2 and Q6 act as a NOR gate. So NAND gate, then NOR gate basically perform as a AND gate. So Q1 and Q2 act as a load. Q3, Q4, Q6, these are the inputs A, B, C are applied to the drain, and from the Q6 we get output. If any input is low, then the corresponding MOSFET is off. That means the Q6 will be inconducting because it gets the voltage. So if it is conducting, That means output will be low. So if anyone is low, then you get low output. If all are high, if ABC all are high, that means Q3, Q4, Q6 are on state. That means Q6 is now off state, no potential because the potential at that point is 0. So here what we get a high output. So when ABC are high, we get high output. When ABC either or all are low, then output we get low. So this is it. And right hand circuit acts as a OR gate. ABC means Q4, Q5, and Q6 are connected parallel. Q1 and Q2 are acting as a load. So basically Q1, Q4, Q5, Q6 construct a NOR gate and Q2 and Q3 act as a NOR gate. So ultimate overall circuit acts as a OR gate. So when any one of the input is high, A, B, C, any one of these high, the corresponding transistor is on. So corresponding transistor only at point K, the potential is 0. The potential 0 means then Q3 switch off, no potential, low level, so Q3 switch off, then at the output will get, because Q2 acts as a load, so we will get higher. If all the inputs are low, means Q4, Q5, Q6 are low or off state, and voltage at K point is high equal to VDD, then Q3 get the voltage, that means we get low output. So this right hand side circuit acts as OR. So what are the characteristics of MOS logic operating speed? Typically, NMOS in NAND gate has a propagation delay of 50 nanoseconds. Noise margin is about 1. Fan out is high, 50. Power drawn, MOS logic circuit drawn small amount of power because of uniquely large impedance. Process complexity, MOS logic is the simplest logic family when it comes to fabrication. It does not require resistance diode or any other component. Only MOS is sufficient. CMOS. CMOS means C means complementary metal oxide semiconductor. CMOS circuit basically use both type of MOS, CMOS as well as NMOS. It has small size, easy of fabrication, low power requirement, relatively simply manufacturing process, high impedance allowing it to be used as a charge storage device. So all these features have contributed to a high level of integration and correspondingly sophisticated logic design. CMOS CMOS. So it consists of one P channel, the N channel. So both the drains are connected to V in, and N channel MOSFET is the source is connected to the ground. P channel MOSFET source is connected to drain. Both the drain connected to out terminal. So when a high voltage is applied to the input voltage, then NMOS is turned on and PMOS is turned off. That means no output. We get the output voltage is equal to the ground potential. When low gate voltage is applied, V in is low, and P channel is in conducting state, but N channel is off state. So the voltage and the output is get equal to VDD. So when input is 0 and the output is high, when input is high, output is low. So this circuit acts as a NOT. CMOS NAND gate. Here circuit is one 2 input NAND gate consists of two P channels of PMOS is Q1 and Q4 connected in parallel, Q2 and Q3 PMOS, NMOS connected in series. Here Q1 and Q2 form one complementary form, and Q3, Q4, Q3, Q4 form another complementary connection. When A and B are logic 1, when A and B are logic 1, so PMOS transistor is off and NMOS transistor is on. So hence, as PMOS is off, So what you get output is low. When both are high level, you get low. When any input is low, then the corresponding N channel MOSFET is off, but P channel MOSFET is on, hence at the output you get high output. Okay? This circuit can operate as a NAND gate. To get the AND gate, the output of this NAND gate can be connected to a NOT gate, then we get easily AND operation. CMOS NOR gate. There are two input NOR gate consist of again two PMOS Q1 and Q2 and another two NMOS Q3 and Q4. So when both inputs are low, A and B are low, so PMOS transistors are on state and NMOS transistors are off state. That means whatever the voltage here VDD will come here. When both inputs are low, you get high output Y is equal to VDD. When any one input is high, the corresponding PMOS is off, that is an N channel MOSFET is on, hence as it is off, so this point output potential will go to ground, so output will be low. So this circuit will act as a NOT gate. Similarly, from this NOT gate, we can easily get OR gate by connecting a CMOS. What are the characteristics of CMOS? Its power distribution. The power consumption of CMOS logic gate is around 10 milliwatt in the range of megahertz. Propagation delay time. The propagation delay time standard CMOS region ranges from 25 to 150 nanoseconds. Noise margin is typically 40 to 45% of the supply voltage. Fan out around 10. So this is all about logic families. Thank you.